How's it going? Welcome back to Crazy Gamers Games and Electronics. We're going to do a little bit more of our basic electronics series from our Make Electronics book. Um, right now we are on experiment 4, which is going to talk about variable resistance. And for this experiment, you're going to need yourself a 9-volt battery. You're going to need yourself a 470 ohm resistor, which I have right there, a 1K resistor, and a 1K resistor, which I have right there. And we'll check those to be sure later. And then you're going to need 2 LEDs. I have a red LED. I have a green LED on this breadboard. And you're going to need 2 of these 1K potentiometers. I have one this way, and I have one here. Now, I have 2 this way, but it talks about taking one of these apart, which, you know what, I'm going to take one apart. So I have an extra potentiometer right here. Now, let me talk a little bit about potentiometers real quick. Now, what a potentiometer is it's a variable resistor. It's just like one of these resistors here, but it is, you could turn the knob. This is a regular resistor, and then this is a potentiometer. And you see that number, let me get the focus going here. There is a number right up top there that says 2K. This is giving me a hard time here. Let's see if I can get this to focus. There we go. See how it says 2K? This means this is a 2000 ohm resistor. And as you can see, you can turn it, and this will change the resistance. If you want the full 2000 ohms, you would connect between this point and this point. And if you want the variable resistance, you would connect from one of these points to the middle point. And that's what we're going to do today. But first, the video talks about basically what's inside one of these variable resistors. Taking one apart does ruin it, basically. I mean, I'm supposing you could try to put it back together. But what I'm going to do here is I'm going to take one of these apart so you guys can see what's inside it. So there's 4 little tabs here. And you peel these up like so. And we're almost there. We got one more to go. And we'll show you what's in one of these. So we'll pull this apart. And then this is the little cap part. And if you look right here, this little plastic part contains a wiper, and as you see here, I don't know if that can be seen, there's a little wiper that spins. It goes across a resistant pad, and it basically can spin. Now, I took off its stop because this has a stop in it, so I can basically spin this around in circle. But if you look at it, it goes, you know, it would start here at the full resistance, and then it would cruise all the way around to where there was no resistance between the middle and the end. So it would be basically 0 ohms, and then all the way the other way would be the full 2000 ohms. See if we can get into this a little bit further. There's a little clip in there. See if I can break that off. I mean, I already took the thing apart. I mean, you can probably put it back together, but probably not the right pliers to do this with. Nah, it's not going to let me get it any further. But hopefully you guys can see inside there to see that little wiper move back and forth against that resistant pad. So that's basically potentiometer, and we'll go ahead and get rid of that. For this video, we're basically going to be taking our 9-volt battery, and you can put your little connector on it. And we're going to put our little connector on the battery here. And then we're going to take our 1K potentiometer and we're going to turn it all the way clockwise. Okay? And then we're going to measure the ohms of this. So we're going to get our meter out. And I'm using a meter with the Clippies. I've talked about these Astro AI meters in the past. They're fantastic meters. So we're going to clip onto the middle. And right now we have the full 1K resistance. And if we turn it, as we turn it down, if I would have put it in the shot, that would have been better. So there we have the full 1K, the 1 and the K up top. And then as we turn it, it drops to 0.8. And now we're at 400 ohms, down to 167 ohms. And then it goes down to 2 ohms. So let's see if we can put it in the middle at 500. All right, there's the middle at 500, and I'm going to put one of these cap knobs on it that if you get them, they come with these caps. So I know that this is the middle. So if I turn it all the way down like that, I got 1,000. If I turn it all the way like that, I got 2, which is basically, it's not nothing, but it's close enough to it for, you know, what we're doing here. So basically that's how that works. So now we're going to turn it all the way counterclockwise. So we have the full 1K resistance. And we're going to slide this out of the way. And then we're going to take our little alligator clips here. We're going to unwind them. And we're going to hook our negative to our negative right here. And you can build this on a breadboard like I did here, but we're doing this, basically we're going to destroy an LED is basically what we're going to do here. So I'm going to go to the middle of this potentiometer in the middle, and then I'm going to come off the middle with my yellow, and I'm going to go to the negative lead on the LED. And if you remember from a previous video, the negative lead is always the shorter lead, and there's also a flat spot on the LED. So I'm going to connect that to the negative lead, and then I'm going to connect my positive to the positive of my battery. Hopefully I can get all this on here without shorting anything out. And we will connect it to our LED. And our LED is going to glow. We turn the lights down. And you can see that glowing a little better. Now, we're going to put that there. Now, as I slowly turn this, you can see that LED getting brighter. And now, if I turn it, you can see how much I turned it on here like this. You can see it glowing on my arm. This is all the way down, and then I'm slowly turning it up. Now right here is at that middle point where there's 500 ohms. Now, a resistor will draw as much current as it can until it destroys itself if there's no resistance in line with it. So basically I'm at 500 ohms, and if I go, I'm about at 250 right there, which is about what you want to run a resistor at, your resistor at for an LED to minimize that current. But I'm going to demonstrate what happens when you take resistance out of the circuit. So as I approach 0, the LED will dim, and it is barely, and there is smoke. So as you can see, the LED burned out. Now let's turn some lights back on so you can see this. And I'll show you what happened here. Let's unhook our batteries. We don't short anything else out. Let's see if we can get this in here. You can see that black spot right there on that LED. There's a black spot in there. Basically, the LED melted and it shorted it out, which then in turn put a short across our resistor, which basically released the magic smoke. So let's see if this resistor is even good anymore. See, this is something that doesn't mention in the book. Your resistor doesn't get destroyed in the book, but it can happen. Yeah, see, now all the way turned all the way clockwise, it's 18 ohms instead of the 2. So the potentiometer, even though it did smoke, it does seem to be fine, but the LED, if I do a test on this LED, if I set my meter to diode and I connect the positive to the positive, it's dead. It should light up. It's dead. It's got the black spot of death. But that's basically, the resistance went away and it basically cooked this LED. Now, you're probably wondering to yourself, what if I want to use a potentiometer with my LED and be able to control it, but I don't want to turn it so far that I have to be careful so I don't burn it out and all that stuff? Well, on this breadboard circuit, I solved this problem. Let's bring this breadboard circuit over here and we'll zoom down in on it here. Okay, and I'll hook my battery up here. And I'll plug it into the power. If you look at this circuit, I have the LED and then I have the potentiometer, but I also have a 470 ohm resistor in series with the potentiometer and the LED. So if I turn this on, which I'm going to do right now, plug in my power in. See, now I have the 9-volt battery powered up to this. And if I turn, okay, I'm not sure why that's not working. I'm going to pause for a second to check this out. Okay, I'm back. Yeah, I got tricked by that faulty resistor color code that got me in the last one. It says it's 470 ohm, but it's 470K. And I put that in the circuit expecting it to be 470, didn't check it with the meter like I should have, and that was my mistake. See, you got to check these things. So I checked this one with the meter, it is 470. So now I'm going to connect the power and our LED lights. Now we have the full 1,470 ohms on this resistance in this circuit. And as I turn it, you can see it slightly gets brighter, but it gets all the way bright as I turn it all the way clockwise. Now between the resistor and ground is that 470 ohm resistor, and I'm not putting any extra resistance through the 1K potentiometer. But as I turn it counterclockwise, it gets dimmer, and I've got now at fully counterclockwise, I have the 1,470 ohms. This goes on to teach us how to check the current in a circuit. And to check the current in a circuit, you have to be in series with the circuit. So the best way to do that without using a bunch of alligator clips and the meter that way, what I'm going to do here is I'm going to do it on the breadboard. And you can buy these multi-packs of they're leads for your multimeter that basically the ends just pull off on it and you can stick new ends on. And even these can be swapped for different size pins, and these are basically breadboard pins. These will fit in the breadboard. So no matter where, this is a series circuit, so no matter where I check the current, it's going to be the same anywhere in the circuit. So I'm going to check it between power, between the positive side and the positive leg of the LED. Now, be careful when you go to do this. You need to put your red lead into the correct amperage spot of your meter. Mine does up to 400 milliamps on this setting, so I'm going to plug my lead in there because I know this isn't going to be more than 407 or but more than 400 milliamps, and I know that because of Ohm's law. I know the voltage is 9 volts, and I know the minimum resistance is 470 ohms. So I could divide that 470 by the voltage, and I would get a current. So let's just double check our math, and we'll do that math right now. Because no, I cannot do that math in my head. So we have 9 volts, and we're going to divide that by the minimum resistance, which is 470, and it's about 19 milliamps at the lowest range. Now, let's just say at the highest range, 9 divided by 1,470, and that is about 6 milliamps. So on the 400 milliamp range, we are good to go. So what I'm going to do is I'm going to pull out this jumper right here, and I'm going to set my meter to DC milliamps, and I'm going to stick the negative there, I'm going to stick the positive there, and then we have all the way counterclockwise, we have 4 milliamps. The math said about 6, so probably the battery voltage is a little higher and the resistance is a little lower. But as I rotate it and I remove some of the resistance, you can see the milliamp rating going up. Now we're at 8, and we are all the way across, and we're about 14.86, so 15 milliamps with just a 470 ohm resistor. Now let us pull that one out and put a, no, we can leave that one in there. So basically 15 milliamps, and that's how you measure current in series with the circuit. But what if you want to look at the potential difference in voltage, which is basically your voltage drop? So in order to do that, I'm going to pull these leads out here, and I'm going to put my little jumper back in, and my LED lights, and then we're going to put our resistance back all the way counterclockwise, and I'm going to switch my meter leads back right away because measuring amperage is a dead short in the circuit, and that could damage your meter if you switch settings or you go to another setting and you're still, or you test it and you got a dead short. That's not good. So now we can go in parallel on this LED and see what the LED's voltage drop is. So I'm going to stick that one there and that one there, and we have about 1.9 volts or 2 volts total onto this LED, which is about the forward voltage of it. So we'll stick those in there, and you can see as we lower the resistance, the voltage goes up a little bit, and it goes to 2 volts. It's not much of a change because the LED adjusts a little bit for the lack of resistance, but not as much as you would think. So, but now let's take a look at the voltage drop across the potentiometer. So we're going to go ahead and crank this back to 1K, and we're going to come in here. I want that one. I want that one and that one. And yeah, I hooked that up backwards. Okay, so right now we're dropping 4.9 volts across the potentiometer, and as I change its resistance and lower it, it's going to drop all the way down to 38 millivolts when it's got zero resistance. But if we go ahead and we hop over here to the voltage drop on this 470 ohm, it's dropping 6.98 volts, but as I increase the resistance of the potentiometer, its voltage drops down to 2 volts. So as you can see, as you change the voltage of this potentiometer, it also changes the voltage drop of the potentiometer, and it will also affect the amount of current flowing in the circuit. So, and current, too much current is what kills the LEDs. That's what killed the LED in the last. When we dropped it down to zero resistance, it was basically able to draw as much current as possible through the battery, and it basically burned up the LED, and it created a dead short, which then put 9 volts through basically the 2 ohms of that that potentiometer that started to smoke. So this chapter goes on to talk about series and parallel resistance, but this video is quite long enough already. So I'm going to talk about series and parallel resistances, and I'm going to touch back on more Ohm's law in the next video. It's not going to be anything really exciting in that video, but you know, it's all basic electronics, and it's stuff you need to know to build your own projects and have fun with electronics. For Crazy Gamers Games and Electronics, I'm the Crazy Gamer. You have a great day.